the only PhD who got out of this program, not because other PhDs were eliminated, but because she was really the only PhD which was foreseen in the project. Let's put it this way. So it was a project where we planned to employ more postdoc level expertise than PhD level expertise. But Karla came in, and I should say, I mean, funny story, Karla came in the day before Germany shut down for COVID. So she barely arrived in Germany when the project was still at the University of Bremen. And all of a sudden she was like, what do I do here? But you pulled through, and now she is a postdoc at the Universidad Autónoma de Mexico. And then it's a great success for her to be here, to look back at what she was doing during this project. Thank you for coming, Karla.
Yeah, thanks, Ale. And thanks for all of you for listening to my presentation. At the beginning, I was a bit worried because I saw like very detailed expose, and I was thinking like, oh, I could many things, but now good that Ale remember that we have not a lot of time to explain of results. So I will talk about the Holocene and Last Interglacial sea level changes in South America, and as Alex seems will heard, the problem of the dating and the problem of the uncertainties is not just a thing from Antarctica. This is something that when we did these sea level data compilations, we face a lot of troubles and a lot of uncertainties that are out there. And I hope that in the next future we can fill some of those gaps. So, most of you may know by now these things that I will explain in the beginning of my exposition, but for further, I hope that the students that were before listening to all the paleo sea level lectures before this helped you to match all the ideas by now. So we have the idea that when we have higher temperatures, we will have smaller ice sheets, and therefore we expect a rising in sea level. But actually, the process is way more complex than that. We have many factors that could modify the sea level locally, but also globally. And this could change the sea level trend in different magnitude, but also in different time scales. So this is a really hard thing to do. And why we do this if this is really complicated to do? Why? Because since the last century, we face this sea level trend of a rising sea level, but we don't know how fast or how high could reach the sea level in the near future. But nowadays, we saw these kind of problems when we face as a society the problems of the sea level rise. And to fulfill these uncertainties in the predictions, we need to use data that cover in various spatio-temporal scales. And which data is this? The paleo sea level data, because if we use just data from tidal gauges or satellite data, we may just have data from the last 100 years. But paleo sea level data, as you may see by now with all the explanations that we have, could help us to constrain some uncertainties that we have with these predictions. So we normally know that through the air climate history, we have changes from glacial to interglacial periods due to the Earth's movement around the sun, but also the tilt and also its own orbit movements, no? And we have, when we analyze the interglacial periods through the past, we have many different interglacials, as you can see in the upper panel. And we normally see that when we have higher temperatures in these interglacial periods, we have normally or generally higher relative sea level. And for that reason, I want to tell you the history of what happened in the Southwestern Atlantic during the Holocene, that is this recent interglacial where we live on, and what happened during the last interglacial. And we did this database analysis in the Southwestern Atlantic. And why the Southwestern Atlantic? Because despite that it is a huge, beautiful area, it has many different characteristics that made it special for sea level research. Some of those are that we have lower chemical weather, so therefore we have a good representation or preservation of the sea level indicators in this area. Also, we have many different indicators date back from the Pleistocene to the Holocene. I will show you just here Pleistocene and Holocene, but you can also see my poster during the Policy Conference when I will show results from the Pleistocene. And generally, we can consider this area as a passive magic. We have just a couple of tectonics in the southern part in Tierra del Fuego, and also a little bit in the north in Rio Grande do Norte in Brazil. So, one important thing for me to highlight is that we use sea level indicators to constrain paleo sea level changes. But to consider a good sea level indicator, these sea level indicators must have at least 4 attributes that I listed here. We need to know the precise location. We need to measure the elevation and associate with a datum. A datum is a point when we can relate this to the sea level. For example, mean sea level, mean high water, all that are datums. And we need to know the indicative meaning. And the indicative meaning is not more than the distribution range of these paleo sea level indicators. For example, here I showed you one of the easiest ones that are the fixed biological indicators. And for example, we have vermetid fossils, and we know the distribution of the recent community of the vermetids, so we know the upper and lower part of the sea level when we can see these kind of indicators, that is from mean sea level to mean low water. And the indicative meaning is this range that we know, indicative range plus the mean point that you can see there, that is the reference water level. And one thing that is really important that also Alex highlighted, we need to know the age, and sometimes this is one of the main problems, more when we date back to the last interglacial, what I will show you. So, the results from the Holocene in the Western Atlantic, so the Holocene is these interglacial periods when we live on, and they start around 12,000 years ago, and we have this beautiful and huge area from Brazil to the Patagonia, Argentina, and Tierra del Fuego, and we split the area. We have 12 areas because we want to gather the area that have similar characteristics in terms of sedimentology, geomorphology, geological history, and so on. And then when we start to analyze the database and all the data that is published in this area, we found out that we have many different indicators. We have around 14 different sea level indicators, each one with their own challenge to determine the indicative meaning of those. And we found that vermetids are the most common indicators from Brazil, but in Argentina and Uruguay, we have beach ridges. So there are many wide different indicators in this area, and we produced a bunch of sea level index points. But a sea level index point is not a sea level indicator. A sea level index point is the discrete past position of the sea level in time and space. And we have a lot of more limiting points that tell you the upper and lower limit of the sea level in this area. And since I need to give a short talk, I just decided to show you just one point in the north, the middle trend, and the southern, but also in my poster you can see the whole data from the whole profile. So here I show you the data from the northern part of Brazil, and in the lower panel from the map you can see the Holocene sea level trend that we get from our data using a spatio-temporal empirical hierarchical model. And in the lower panel, you can see the relative sea level rate of change. And as you can see, the rate is higher in the beginning of the Holocene. And this is something that we expect because we have the deglaciation and then the rising of the sea level through the Holocene. And in this area, the trend is that we have a mid-Holocene high stand and then a subsequent fall through the present position. And this is something that we expect regarding the glaciostatical models that we run in this area. If we move in the southern Brazil, it's the same. We have a higher rise rate of sea level change in the early Holocene. We have this mid-Holocene high stand with a subsequent fall to the present that is common from the far field areas. And we still having this trend in the southern part, but you can see as we move southward, we have a higher relative sea level, and it comes earlier in time, which is what we expect with these glaciostatic signals. But also remember that here we have sort of tectonic that could also modify this value that we have from sea level, because these values are not corrected for the positional movements. This is something really important to have in mind. And despite all this, and that we have uncertainties in terms of age and elevations, and a lot more uncertainties, we can see that we have a high sand in the mid-Holocene from 2 to 4 meters above the present level. And what happened during the last interglacial? Since it's an older period, then the challenges increase. As you see in the Antarctica talk, the same happened here. Here we did a database that covered the Brazil area, go to the north until Honduras, but despite you just see small sea level index points that are dotted there in the map, I review the whole area. But most of the area and most of the papers should be rejected because we have a lot of uncertainties. And the elementary or the principal uncertainty is that we don't know the age. They just mention a radiocarbon date as a limiting date, and then they infer, okay, we have these deposits that belong to the Holocene, and then this in the back should be last interglacial, but we are not sure about that. So since we have this uncertainty, we cannot take this data as true. So there's a lot of data, and they mention that you have a continuum deposits from Brazil to Honduras that could be dated to the last interglacials with these uncertainties. We found 6 main types of sea level indicators. The most common from Brazil are ophomorphoborous. We have coral reef terraces in the islands Bonaire and Curaçao. And we have marine terraces also described in this huge area. We produce 55 standardized sea levels index points, and here I show you the trends of the sea level, of the relative sea level. This here is the northern part of Brazil, this is the southern part, so these go up in the map, and as you can see, the northern part have the higher relative sea levels, and this could be associated to these neotectonical effects some Brazilians talk about, but so far no one correct this uplift grade that we have in this area. So this is something that needs to be done in future research. And we have here the values from Curaçao and Bonaire areas, and you can see there is a difference in the elevation from the landward side, from the windward side, so both islands are tilted, and we have higher relative sea level values from 12, I think is the highest values that we have. And these are just a small sea level index, like not much sea level index points that we find in Provincia and San Andres Island from Colombia, and we have these values. And here we have another trend, as Andrea mentioned in the beginning, what are these peak of the sea level in the Southwestern Atlantic goes from 6 to 8 meters, more or less. And this is what we found, but again, data quality, not much of the data consider these attributes that we should have for a sea level indicator we still having a lot of uncertainties that we need to fulfill. But despite that, we have a good amount of data. Now we are aware of the uncertainties. We can fulfill these pole-to-pole transit of databases from the Holocene and the last interglacial, and we know what we could do next to fulfill the uncertainties that we have. So this is all for my talk, and later on, Didra will tell you about the last interglacial in Argentina to follow up my speech. So thank you for your attention, and also thanks, Ale, for the opportunity and for the patience. I know that it was a hard road for both of those, but thank you for everything.